Good morning, friends. We'll start API 510. Preheat or controllable deposition welding (CDW) methods as alternative to PWST. Preheat and CDW, as described in 8.1, 6.4, 2.2, and 8.1, 6.4, 2.3, may be used in lieu of PWST where PWST is inadvisable or mechanically unnecessary. Prior to using an alternative method, the metallurgical review conducted by an engineer shall be performed to assure the proposed alternative is scheduled for application. The review should consider factors such as the reason for the original PWST of the equipment, susceptibility to stress, corrosion, cracking, stresses in the location of the weld, susceptibility to high temperature hydrogen attack, susceptibility to creep, etc. The inspector is responsible for verifying that the methods used are in accordance with owner-user specification and the requirements of the section. Selection of the welding method used shall be based on the rules of construction code applicable to the work planned. Vessels constructed of steels other than listed in 8.1.7.4.3.2 and 3.33 that initially require PWST shall be post-weld heat treated if alteration or repairs involving pressure boundary welding are performed. Preheating method of notch toughness testing not required. The preheating method when performed in lieu of PWST is limited to the following material and weld process. The material shall be limited to P1 group 1, 2 and 3, P3 group 1 and 2, excluding MN, MO steels in group 2. The welding shall be limited to shielded metal arc welding SMAW, gas metal arc welding GMAW, and gas tungsten arc welding GTAW. The preheat method shall be performed as follows. The weld area shall be preheated and maintained at a minimum temperature of 300 degrees Fahrenheit, 150 degrees centigrade during welding. The 300 degrees Fahrenheit, 150 degrees centigrade temperature should be checked to assure that 4-inch 100 mm of the material of 4 times the material thickness, whichever is greater on each side of the groove, is maintained at a minimum temperature during the welding. The maximum interpass temperature shall not exceed 600 degrees Fahrenheit, 315 degrees centigrade. When the weld doesn't penetrate through the full thickness of the material, the minimum preheat and maximum interpass temperature need only maintained at a distance of 4-inch or 4 times the depth of the repair weld, whichever is greater on each side of the joint. Notch toughness testing is not required when using the preheat method in lieu of PWST. CDW method, notch toughness testing required. The CDW method may be used in lieu of PWST in accordance with the following. Notch toughness testing, such that the established ASME code section 8 division 1 parts UG 84 UCS 66 is necessary when impact tests are required by the original code of construction or the construction code applicable to the work plan. The materials shall be limited for P number 1, 3 and P number 4 steels. The welding shall be limited to SMAW, GTW and GMAW. The weld procedure specifications shall be developed and qualified for each application. The welding procedures shall define the preheat temperature and interpass temperature and include Preheat temperature requirement in item F8. The qualification thickness for test plates and repair grooves shall be in accordance with table 8.1. The test material for the welding procedure qualifications shall be of the same material specification, including specification type, grade, class, condition of heat treatment, original material specification for the repair. If the original material specification is obsolete, the test material used should be conformed to as much as possible to the material used for construction, but in no case shall be material be lower in strength or to have a carbon content more than 0.35%. When the impact tests are required by the construction code applicable to the work plan, the procedure qualification record PQR shall include sufficient tests to determine if the toughness of the weld metal and the heat affected zone of the base metal in the as welded condition is adequate in the MDMT, such as the criteria used in ASME code section 8 division 1 part UG 84 UCS 66. If special hardness limits are necessary, NAS SP0472, NAS MR0103 for stress corrosion cracking resistance. PQR shall include hardness test as well. The supplementary essential variable ASME code section 9 paragraph QW250 shall apply. The maximum weld input for each layer shall have exceed the used in the procedure qualification test. The minimum preheat temperature for welding shall not be less than that used in the procedure qualification test. The maximum interpass temperature for welding shall not be greater than that used in the procedure qualification test. The preheat temperature shall be checked as assure that 100 mm 4 inch the material 4 times the material thickness, whichever is greater on each side of the weld joint, will maintain at a minimum temperature during the welding. When the weld doesn't penetrate through the full thickness of the material, the minimum preheat temperature need only be maintained at a distance of 4 inch or 4 times the depth of the repair weld, whichever is greater than each side of the weld. The maximum interpass temperature of the welding shall not be greater than that used in the procedure qualification test. The preheat temperature shall be checked to assure that 4 inch 100 mm the material or 4 times the material thickness Whichever is greater on each side of the weld joint will be maintained at a minimum temperature during welding. When the weld doesn't penetrate through the full thickness of the material, the minimum preheat temperature need only maintain at a distance of 4 inch or 4 times the depth of the repair weld, whichever is greater in each side of the joint. Use of electrodes in the filler metals that are classified by the filler metal specification with an optional supplement diffusible hydrogen designator of H8 or lower. When shielding gases are used in with a process, the gas shall exhibit a dew point that no higher than 60 degrees Fahrenheit with minus 50 degree centigrade. Surface on which welding will be done shall be maintained in a dry condition during the welding and free from rust, mill scale, and hydrogen producing contaminants such as oil, grease, and other organic materials. H8 means 8 grams per million, 8 parts per million. Per million. The welding technique shall be CDW, temper bead, or half bead technique. For welds made by SMAW after completion of the welding and without allowing the weldment to cool below the minimum preheat temperature, the temperature of the weldment shall be raised to a temperature of 500 degrees Fahrenheit plus minus 50 degrees Fahrenheit to 60 degree plus minus 30 degrees centigrade for a minimum period of 2 hours to assist outgassing diffusion of any weld metal hydrogen picked up during the welding. This hydrogen backout treatment may be omitted provided the electrode is classified by the filler metal specification with an optional supplemental diffusible hydrogen designator of H4. After the finished repair weld has cooled, the final temper bit reinforcement layer shall be removed, leaving the welds substantially flush with the surface of the base metal. Refer WRC Bulletin 412 for the additional supporting technical information regarding CDW. Qualification limits for the base metal and weld metal thickness for CDW method. Depth T of test, groove weld, T, repair groove depth qualified less than T, thickness T of the test coupon 2 inch, less than 50 mm, thickness of the T test coupon welded, thickness of base metal qualified less than T, greater than 2 inch, then it is 2 inch in thickness base metal qualified to unlimited. The depth of groove used for procedure qualification shall be deep enough to allow removal of the required test specimen. After the weld is completed, it shall be examined again by the appropriate NDE technique specified in the repair specification to determine that no defects exist using acceptance standard acceptable to the inspector or the applicable construction code. New welds as part of repair or alteration in preservation that were originally required to be radiographed. Circumferential and longitudinal welds may be by the construction code shall radiographically examined in accordance with the construction code. In situation where it is not practical to perform radiography, the accessible surface of each Non-radiographed new welds shall be fully examined using UT in lieu of RT and or either appropriate NDT techniques to determine that no defects exist. If other techniques are used rather than UT in lieu of RT, joint efficiency should be reduced to the value corresponding to no radiography, where use of NDT techniques specified by construction code is not possible, or practical alternative NDT technique may be used provided they are approved by engineer and inspector. Acceptance criteria for welded repairs or alterations should be in accordance with the applicable section of ASME code or another applicable vessel rating code. Weld inspection for vessels subjected to brittle fracture. A vessel construction of material that may be subject to brittle fracture as per API 579.1 ASME FFS Part 3 or other analysis from either normal or abnormal service, including startup, shutdown, and pressure testing. Appropriate inspection should be considered after welded repairs or alterations. Flaws, notches, and other stress rises could initiate a brittle fracture in subsequent pressure testing or service. MT or other effective service ND methods should be considered. Inspection techniques should be selected to detect critical flaws as determined by FFS assessment. Re-rating. Re-rating a pressure vessel by changing its design temperature, minimum metal design temperature, or its MAWP may be done only after all of the following requirements have been met. Calculation performed by either the manufacturer or the owner user engineer or his designee representative experienced in the pressure vessel design, fabricator, or inspection shall justify re-rating. The re-rating shall be performed in accordance with the requirement of vessel's construction code. Alternatively, calculations can be made using the appropriate formulas in the latest edition of the applicable construction code, provided all the vessel's essential details comply with the appropriate equipment of BSME code. If the vessel is designed into an edition of addendum ASME code earlier than 1999 addendum and was not designed to ASME code case 2290 or ASME code case 2278, it may be referred to the latest edition addendum of the ASME code if permitted by figure 8.1. Notice that the vessel built to a code earlier than 1968, the original design allowable stress based on design factor 4 and 5 shall be used. Current inspection records verify that the pressure vessel is satisfactory for the purpose of service conditions and that the corrosion allowance provided is appropriate. In an increase in the allowable working pressure or design temperature shall be based on thickness data obtained from the recent internal or on-stream inspection. The vessel shall be pressure tested using the applicable testing formulas for the code used to perform re-rating calculations unless either of the following is true. The pressure vessel has at some time been pressure tested to test pressure equal to or higher than the test pressure required by the construction code, and the vessel integrity is confirmed by the physical non-destructive evaluation inspection technique in lieu of testing. The re-rating is acceptable to the engineer. Obtain original vessel data. Was vessel built to 1969, 68 or later edition of ASME code C01? ASME code identified as ASME 600 division 1. Note 1. Okay. Was the vessel material listed in the latest edition of addendum of the ASME code C note? Was vessel material current specification? Is allowable stress and read temperature as per latest edition addendum for ASME code? Was the vessel material originally certified using UG10 of ASME code? Review operational history. Can vessel material be certified using UG10 of the ASME code? Can vessel material properties meet a current material specification? Has the material been degraded because operation C note 3? Review operational history. Does the material toughness meet the latest edition addendum of the ASME code toughness requirements? Re-rate vessel of component using latest edition addendum of ASME code allowable. Stress. Do the vessel components satisfy the impact toughness required in ASME API 579 section 3 or other recognized FFS standards for the related condition? Vessel component cannot be re-rated using the latest edition addendum of the ASME code allowing stress. If the material is not meet a current material specification. Can the vessel material be certified using EG10 of the ASME code? In both the cases, do the vessel components satisfy the impact toughness requirement of ASME 579, section 3 or other recognized FFS standards? Then re-rate. Re-rating of vessels using the latest edition addendum of ASME code. The pressure vessel re-rating will be considered complete with the attachment of an additional nameplate or additional stamping that carries the information in figure 8.2, re-rated by date, re-rated, SAP number, date, MWP, PSIG, @ Fahrenheit, Fahrenheit, at PSIG, test pressure PSIG, sample additional nameplate. Alternative rules for EP pressure vessels. Okay, we'll stop here.